Hello, friends. Thank you so much for tuning in once again. I'm deeply honored by your gesture of always getting to know what I have to present to you. Please, I would ask you to press that bell button if you have subscribed, and if you haven't subscribed, please do subscribe and press the button so that in case I upload a video, you'll be alerted. And thank you so much for your support thus far. In this session, I would want us to look at rationalization of the denominator. Now, if you have a surd or a fraction whose denominator is a surd, from time to time we may be required to write the denominator in such a way that there is no surd. That process is what we are referring to as rationalization of the denominator. Now, rationalizing the denominator doesn't change the meaning of the fraction. It only changes the appearance of the fraction. And let's take one simple example. For instance, you could have a fraction. You could be asked, for example, to rationalize the denominator in, that is the first example, in say a fraction like 2 over root 7. Okay, this fraction, you see in the denominator we have a surd. Now we are asked to rationalize the denominator. In other words, to write the denominator such that there is no surd in it. Now in this case, what we will need to do is, let's consider the effect of multiplying the denominator by 7 and also the numerator by root 7. Sorry, not 7, but root 7. So what we have here, in our case here, we'll have 2 root 7 in the numerator. And then look at this. We said when you're multiplying surds, as long as they're of the same order, you can multiply the numbers under the radical, as you can see here. And this is the same as 2 root 7 over root 49. And we know that 49 is a perfect square. So our answer here is 2 root 7 over 7. Now, this is the same as 2 over root 7, the first fraction that we had. So when written in this form, we say we have rationalized the denominator. So in the original case, we had a surd in the denominator. In the final case, we don't have a surd in the denominator. And remember, we haven't changed the numerical meaning, the mathematical meaning of this fraction. We have only changed its appearance. So this is the rationalized form. If on the other hand, let's say, consider another example, like we have a given like, let's say 1 over 2 root 5. And we are asked to rationalize the denominator. Okay, we have 1 over 2 root 5. I hope that is clear. So if you're asked to rationalize the denominator, now in this case, again, we take the effect. Let's just have the surd, this 2 root 5. Now, always we consider what is in the denominator, because remember the effect is rationalizing the denominator. So our focus is in the denominator. So here we have 2 root 5. These are mixed surd. When a surd is multiplied by a rational number, is said to be mixed surd. So what we do in this case, we look at the sad part, the Surds part, not the sad as in the opposite of happiness. So here we have root 5. So we multiply this denominator by root 5, and then the numerator also by root 5. Remember, what we use to multiply the numerator is dictated or determined by what we did in the denominator. So the focus is normally in the denominator. It's the denominator that will determine what we use to multiply both the denominator and the numerator. So like in this case, we have 2 root 5. So we take the surd in the denominator here, which is root 5. So root 5 multiplied by root 5. Now in this case, we'll have root 5 in the numerator, root 5 times by 1, which is root 5. And in the denominator, we'll have 2 root 25. 2 root 25, and root 25, as we know, is actually 5. So we'll have root 5 over 10. Remember, we have 2 multiplied by now the square root of 25, which is 5, and that gives you 10. So this is the rationalized, the fraction now with the rationalized denominator of the original fraction, which we had as 1 over 2 root 5. Okay, let's consider another case. What happens, for instance, if we have, let's look at example 3, that was example 2. If we have, for instance, we have 2, or let's say 2 root 11 over 3 root 2. Then we are asked to rationalize the denominator. Look at this fraction, fraction 2 root 11 divided by 3 root 2. So what we do, again, as I said earlier, the focus is in the denominator. Remember, in this case, both the numerator and the denominator have surds. But because we are rationalizing the denominator, we focus on the surd in the denominator. So in this case, we'll have our 2 root 11 over 3 root 2. Then we multiply the denominator. We consider the surd in the denominator here. Which surd we have there? Root 2. So we have root 2. And what we use to multiply the denominator must also be used to multiply the numerator, what we have there. And so this gives us now 2 multiplied by root 11 multiplied by root 2 over 3 multiplied by root 2 multiplied by 2. Remember what we said earlier, when the order is the same for the surds, you can simply multiply the numbers under the radical by each other. So like in the above case, also we'll have this is the same as 2 times root of 11 by 2 over, now in the denominator here, we have 2 or 3, sorry, multiplied by root 4. Now with the practice, you'll realize you'll avoid most of these steps. I'm only taking longer to reach the answer because I'm explaining to you, but with the practice, you'll avoid most of these steps that we are showing here. So in our case, the final answer now becomes 2 root 22 over, remember 3 multiplied by root 4, but root 4 is now 2, which is over 6. 3 by 2 is 6. And you can see you have 2 multiplied by root 22 over 6. Now 2 and 6 here are rational numbers, and we can simplify, and this gives us root 22 over 3. Now this is the fraction with the rationalized denominator. The fraction, remember the original fraction is what we had there as 2 root 11 over 3 root 2. So it reduces to this, and you see this is what we have with the rationalized denominator. The meaning has not changed of this fraction, only the appearance has changed. Reason, we have rationalized the denominator. I hope that was beneficial to you. If you have any other question, you can ask. Now in the next session, we'll come to do more examples on rationalizing the denominator. In this case, we dealt with a single term denominator, what we would also call a monomial. We also have monomial. We have monomial surds and binomial surds. So what we have here are monomial surds. In the next class, we'll look at binomial surds and how to rationalize their denominator. Thank you so much. Have a nice time and take care.